Hello, class. This is Mr. Gibson with our first lesson for this semester. We are starting in chapter 1 under number sense and problem solving. Now, I know that we all have different books, so what we will have to do, like we did in class, we will go over what page numbers that you will need to find the particular lessons on. So the page numbers you may see here on screen may not match up with your book, but the concepts are the same. So now we start here with lesson 1, compare and order numbers. Now, just to go over our key concepts that we're going to go over with this lesson, we're going to deal with place value, comparing and ordering values, and rounding numbers. These are our three main concepts that we're going to cover. Now, with place value, if you notice here, we're not dealing with decimals. We're just dealing with whole numbers that's in front of the decimal. So you would not be using the word and whenever you say a number. You only use the word and in mathematics to describe a decimal. Okay, so now with that being said, we have 1,479. And if you notice, each of these digits are put in their place value. So the 9 is in the ones place, the 7 is in the tens place, the 4 is in the hundreds place, and the 1 is in the thousands place. But what we will do, we will go over this more in depth when we get to the practice problem. Okay, now comparing and ordering numbers. Now, basically, to compare and order numbers, we're dealing with ordering numbers from the least to the greatest. Now, typically, what we would do, we would basically, if we cannot figure out like which numbers are larger than the other, typically we would line them up by their place value. And as soon as we get to the highest number in the particular place value, then that will let us know which one is the higher number. Especially like here, we have 342 and 317. These and also 98. We have two three-digit numbers and one double-digit number. So we know a three-digit number that begins with a number that's not zero is always going to be larger than the two-digit number. Okay, so we know the 342 and 317 is larger than 98. So we don't have to worry about that. Now we come here to the three-digit numbers. We will compare the 2 with the 7. Now we know 7 is larger than 2, but we continue to go on until we get to that last digit since they're the same length. So if you look here, we have the tens. 4 is larger than 1. But if you look at the hundreds, these first digits are the same. So since the larger place values are the same, then you will go to the next place value, which here would be the tens. 4 is larger than 1, so that lets us know that 342 is larger than 317. So when we go from least to greatest, we know 98 is the lowest, then comes 317, then 342. But again, we will go more in depth with this as we go through the practice problem. Now we come down here to rounding numbers. Now, a lot of people have trouble with rounding numbers, but we're not going to have that issue here. We're going to go through this and stomp this out. Okay, now, when we round numbers, first of all, we need to know our place values. And what we're doing here, we're only rounding whole numbers. We're not dealing with decimals because decimals have some of the same properties, but are still a little different. So what happens here is this. When we look at our place values, if I say I want you to round to the hundreds place, you'll go to the hundreds place, and then you'll go to the digit right next to the hundred place to the right. So you'll go to the place value that's slightly lower than the other place value. So for the hundreds, the next place value down would be the tens. So if we're rounding to the hundreds place, we have to look at the tens place. That will determine if we round up if we round the hundreds place up or if we leave the hundreds place the same. So to determine that, when we look at that other place value, in this case it's the tens, any digit that's 5, 6, 7, 8, or 9, if you get any of those digits, so I'll write that down, digits 5 through 9. If you get digits 5 through 9, you round up. If you get digits 0 through 4, you leave the place value the same. And everything behind it, and when I say behind it, I'm talking about the place value, will become zeros, 0 or zeros. And that's the same thing with the round up. You'll round up and everything behind it will become zeros, a 0 or zeros. For example, I said that I wanted you all to round this to the hundreds place, this 1,479. So if we round this to the hundreds place, we'll go here. This is a 7. We'll go to the tens place. This 7 falls in between the 5 through 9. So you would take this place value, this 4, and you would round it up by 1. So this 4 will become 5. Everything behind it will become zeros. So rounding 1,479 to the hundreds place will leave you 1,500. And again, we're going to go over more problems like this in the practice. Okay, so now, well, let me do another number because I want you to see what it looks like when the number stays the same. So let's say we have 1,419. Okay, and we're still rounding to the hundreds place. We'll look here at the tens place, and that's 1. This 1 falls in at 0 through 4 for the digits. So we leave this place value the same. So we'll bring out our 1 and our 4. Everything behind this place value will become 0. So if we were rounding to the hundreds place with 1,419, we would end up with 1,400. Over here, we rounded to the hundreds place with 1,479, and we ended up with 1,500. There's a big difference. Okay, so now we go on to the next page to the practice problems. Now, if you notice here, we have, it looks like 25 practice problems. And it tells us that the answers and explanations begin on page 661. You will have to look in your individual textbook to see if that's where the answers and explanations begin. But I will go over this. So now we're going to look at practice 1A. And we look at, it says, write the digit from the number below that corresponds to the listed place value. The first one is done for you. So let me write this down. Okay, so 1 is the 100,000s. 2 is the hundreds. 3 is the ones, and so on. Let me write this down really quick. And 7 is the 10,000. Okay, I'm gonna put these blanks in front like they do in the textbook to signify the digits that we will put here. Okay, so now the number that we're working with and I'll write the number below here, is 1,436,879. Now, we're going to have to go through and determine what place value each of these digits are in. So now we've already been told that this 4 is in 100,000s place. Now, just going through this, now if you need to pause or rewind the video, feel free to do it. But what you would do is, this is 100,000s. First of all, this is millions. So this is millions. And I'm going to try and write it here, but I know I'm going to run out of space. But this is millions. This is 100,000s. This right here is 10,000. This 6 here is thousands. This 8 is hundreds. This 7, I'm gonna just write it here, is tens. And finally, we know this 9 is ones. Okay, now I was not able to write it like the book has it. If you go back to the previous page, to our example, you see how it's written, basically going this way, sideways here, but I can't really write like that. So now, we'll go through. They say 100,000s. The 4 is in 100,000s place, so we put 4. Next, we look for hundreds. We notice here that the 8 is in the hundreds place, so that would be 8. And the ones place is 9. In the millions place is 1. In the thousands place we have 6. In the tens place we have 7. And in the 10,000s place we have 3. And that is basically it. Okay, so now, again, if you all have any questions, feel free to ask during our next class session. Okay, next. We go here to B. It says round these numbers as directed. So number 8. Now I'm not going to write down all of the words, but it does say for number 8, round 544 to the nearest 100. So if we have 544, first of all, we have to determine what the hundreds place is. We know this is ones, tens, hundreds. So they want us to round to the hundreds place. So again, we go to the place value directly to the right of it, which is tens, which is this 4. So now we know from 0 to 4, we don't round up. We leave this place value the same. So we'll bring down our 5. Everything behind the 5, because we're not dealing with decimals, becomes 0. So our final answer here for number 8 is 500. Okay, number 9. It says here round 76 to the nearest 10. So we have 76. We're trying to find the tens place. The tens place here is 7. So we'll go directly to the right, which is the ones place, which is the 6. So this 6 falls in between the 5 through 9. So that means we round up this place value by 1. So that'll become 8. And everything behind this place value becomes 0. Okay, number 10. It says round 1,058 to the nearest 100. So we have 1,058. The number that's in the hundreds, the 100 place value is 0. So the digit directly next to it, which is in the tens place, is this 5. This 5 falls in the 5 through 9. So we would add 1 to this hundreds place and make that 0 or 1. And everything behind this hundreds place becomes 0. Okay, so now we move on to 11. Now, number 11, it says round 11,632 to the nearest thousand. So 11,632 to the nearest thousand. So we have to determine where the thousands place is. We have ones, tens, hundreds. This is the thousands place. So we'll go to the place value directly to the right of it, which happens to be the hundreds place. This 6 falls in between 5 through 9. So that means we would add 1 to the thousands place. So this will give us 12, comma, and all three of these digits will become zeros. Okay, so now we're going to go to problem 12. It says round 1,525 to the nearest thousand. 1,525 to the nearest thousand. So the thousands place is this 1. Directly to the right of this is the hundreds place, which is a 5. That's 5 through 9. So we know we add 1 to the thousands place, and everything behind the thousands place becomes zeros. So 13, it says round 84 to the nearest 100. So we had 84. Now, they want us to round to the nearest 100. Now, this problem here is a little unique because as you see, we do not have a digit in the hundreds place, but there's actually a number there. 84 is the same as saying 084. Now, we typically don't write math like that, but you have to get that in your mind when they're asking you to round to a place value that you do not see. So if they're asking you to round to the hundreds place, you will go to the digits directly to the right of the 0, which is 8. And then that falls in between 5 through 9, so this 0 becomes a 1. And 84, the 8 and 4 both become 0. So 84 rounds to 100. Okay, so now we'll go down to C. It says in each of the following pairs, which number is greater? So we will have problem 14, and we have 100 or 89. Now we know based upon our numbers, we know 100 is greater. But, well, let's just go with that. We know the 100 is greater, so our answer here would be 100. So then we will go to problem 15. With problem 15, we have 339 or 341. Now this is where I would want you all to do just some comparison. So what you could do is line both of these numbers up. You have 339 over 341. And since they have the same amount of digits, we'll first start with the highest place value, which is the hundreds place. We got the same numbers in the hundreds place, which is the 3s. So we know that doesn't determine which one is the highest. So we'll go to the tens place. We got 3 in the tens place here, 4 in the tens place here. So this is supposed to be 341. So 341 is actually the larger number. So that's how you go when you have the numbers that have the same length or the same amount of digits. You start with the highest place value and work your way down. Whichever one has the highest number or highest digit in that place value is the greater number. Okay, so now we will go to 16. I'm going to go up here because I have some empty space here. So 16, we have 1,099 or 1,145. So we could line them up like we did problem 15. We have 1,099 over 1,145. If you notice, our thousands place is the same with 1. But then when we come to our hundreds place, this bottom number has a 1 and the top number has a 0. 1 is larger than 0, so this is your greater value. It's 1,145. Okay, now We move on to problem 17. Problem 17, we have 125,391. And I'm just going to line this up. We will have 119,450. So again, we go to the hundred thousands place. They're the same. So then we go to the 10,000s place. This has a 2, this has a 1. So that means this is the larger value. So it's 125,391. And that is the final answer for problem 17. Now we go to problem 18. Now with problem 18, it says write these numbers in order from least to greatest. Okay, so this is going to take a little more work, but it's not that bad. So if we look at problem 18, we have 23, 18, 45, and 39. Now, if you notice, all four of these digits, well, all four of these numbers, not digits, but all four of these numbers have only 2 digits. So what we could do, we could line them up, or we could just look at their digits. So we want to go from least to greatest. So we look here to see if any of the digits are the same. They're not in the tens place. So we will look at the lowest 10 place number, which would be 1. So that would be 18. Then the next would be 2, which would be 23. The next would be 3, which is 39. And finally, the largest would be 45. That is from the least to the greatest. Now we go to 19. Problem 19, we have 111. We have 89. We have 109. And then we have 91. Okay, so taking a look at this, you notice that we have 2 3-digit numbers and 2 2-digit numbers. So what we will first compare is the 2 2-digit numbers. Oh, and by the way, let me say this disclaimer. If you notice here with our 2 3-digit numbers, if the first digit of those 3-digit numbers was 0, then it would be basically the same as a 2-digit number. Because remember what we did back up here in problem 13? This was a 2-digit number. Then we put a 0 in front, and that made it a 3-digit number. But it still equals 84. But down here, we don't have a 0 in front, so this is a 3-digit number, and so now we're going to compare the 2-digit numbers. So we have an 8 and a 9. These numbers are not the same, so we know 89 goes first, 91 goes second. Now we're going to compare the 3-digit numbers. If you notice, the first digit of both of the 3-digit numbers are the same. The second digit, which is in the tens place, this has a 1, this has a 0. We know this is a smaller value because 1 is larger than 0. So this would be 109, 111. Okay, now we go to problem 20. With problem 20, we have 1,087, we have 932, we have 909, and we also have 1,139. Now, if you notice here, we have 2 4-digit numbers and 2 3-digit numbers, and none of the lead numbers here is 0. So we look here at the 2 3-digit numbers. Both of them in the hundreds place have a 9, so we go to the tens place. We know 3 is larger than 0, and since we're going from least to greatest, the 909 will go first, then the 932. Now we're left with the 2 4-digit numbers. So if you notice in the thousands place, we have a 1, which is the same. So we go to the hundreds place. 0 and 1. We know 1 is larger than 0. So our next number will be 1,087. And our last number will be 1,139. 139. Okay, now for 21, I'm going to write 21 down here because we have a lot of 4-digit numbers here. For 21, we have 1,429, 1,420, 1,432, and 1,425. Now, when I said and here, I was not referring to a decimal. I was just saying that like you do in English with a series. So now, when we look here, we have all 4-digit numbers. So we'll look at the thousands place. All of them are the same. Now we go to the hundreds place. All of them are the same. Now we go to the tens place. Now the tens place, we have 2s and we have a 3. So we know this 3 is larger than all of them because all of the rest has 2s. So our last value will be this 1,432. That will be our last value. So now we have to determine what our first value is. So if you notice, the first 3 digits of these 3 numbers are the same. So we look at the last digit. We have 9, 0, and 5. We know 0 is the smallest. So we have 1,420. And then 5 is the next smallest. So we have 1,425. And then the third value will be 1,429. And that is the order. So now we go here to problem 22. For problem 22, we have 12,071. Then we have 11,098. And then finally, we have 12,131. Yeah, I ran out of space here, but as you all could see, we got this in here. Okay, so now we have all 5-digit numbers. All of them start with 1. So we can't do any elimination here. So this is the 10,000s place. Now we go to the thousands place. We have 2 values with the 2 and 1 value with the 1. So we know this 11,098 is our smallest value. Now we have to find our next value here. Okay, so our next smallest value. So if you notice, the first 2 digits are the same. We go to the third digit. We have 0 and 1. We know 1 is larger than 0. So our next value will be 12,071. And then our last value would be the 12,131. So that took care of problem 22. Now we move on to problem 23. So problem 23, we have 15,356. We have 15,309. We have 15,298. So now we have all 5-digit numbers. No number is leading with a 0. So we go to the first digit for each one of these values. First digit is 1, so it's all the same. Second digit is 5, it's all the same. The third digit is where it changes. We have 2 of them with a 3 and the last one with a 2. So we know 3 is larger than 2. So we have 15,298 will be our least value. So now we're trying to find the next smallest. So we go here to the tens place, 5 and 0. We know 5 is larger than 0. So our next smallest would be 15,309. And then our last value would be 15,356. And that is our final answer. Now we come here to problem 24. It says, choose the one best answer to each question. Now, when they say the one best answer, it doesn't necessarily mean that the answer is going to be absolutely correct. What it's saying is which one gives you the best answer that's provided to you. So we go here, it says when stacking items, the heaviest item should be placed at the bottom. Starting at the bottom, in what order should items weighing 45 pounds, 40 pounds, 50 pounds, and 48 pounds be stacked? Okay, so it says the heaviest item should be placed at the bottom. So they tell us to start from the bottom. If they're telling us to start from the bottom, so your first number is supposed to indicate your bottom. So if you look here at A, B, C, and D, if you notice with all of them, they all have all of the numbers that's provided, the 45, the 40, 50, and 48. So that's good. But we know with process of elimination, we know that 50, since it's the heaviest, has to be first because they want us to go from the bottom to the top. So that means A and B is gone. Now we look for C, we look at C and D. Both of them start with 50 on the bottom. So we know our next heaviest weight is 48, which only C has. So C, if you look at C, it has 50, 48, 45, and 40. So your answer here would be C for 24. Now for 25, it says, which of the following correctly shows 1,543,976 rounded to the nearest 100,000? So let's write this number out. 1,543,976. So they want us to round to the nearest 100,000. So we need to get to the 100,000s place. So we have ones, tens, hundreds, thousands, 10,000, 100,000. So the 5 is in the 100,000s place. So we look at the digit directly to the right of the 5, which is in the 10,000s place, which is this 4. It falls in between 0 to 4, so that means this 5 is not affected. So we'll write down the 1 and the 5, and all of the digits behind become zeros. And that is the final answer. So that answer would be C as well. So your answer here is C. So that completes the first lesson, the first practice portion. So I will upload this video so you all can have it to take a look at it and ask any questions that you have. Have a wonderful day.